Good afternoon. I want to quickly do a video for follow up on the symbolic competition that we had last Tuesday, I think, Monday or Tuesday. Now, I want to make a quick review, and then before I move to the last topic on Introduction to Matlab. This is DCE110, Introduction to Computer Design and Drafting. We have done the electronic workbench. We are now in Matlab, Introduction to Matlab. Now we'll be doing the AutoCAD as the last application in this course. Now I want to quickly do a quick overview on plots. I want to do some review on plotting so that you can get some things about that. And after plotting, I also look at graphics, and then I also quickly look at a brief summary of all that we have done under symbolic computation, comprising of algebraic solutions, calculus, that is differentiation, integration, and polynomials, solving equations with symbolic computation, SIMs. Now, this is I will just cover them to add to the previous so that you can have a better understanding, and then you can visit tutorialpoint.com for more examples, for more tutorials. So quickly, I want to start. Okay, I want to start this. Okay, this is introduction to plotting. This is plotting in Matlab. Now, Matlab allows us to do plotting. To plot the graph of a function, you need to take the following step. Define x by specifying the range of values for the variable x for which the function will be plotted. Define the function y is equal to f of x. Okay, and then call the plot command as plot x comma y in brackets. So these are just the steps you need to take. Now define x by specifying the range of values that the variable x will take for which the function will be plotted. And then define the function y is equal to f of x. Okay, normally that is the standard statement, and then you can call we call the plot command as plot bracket x comma y in bracket close. Now, for example, let's demonstrate the concept by using this simple function y is equal to x for the range of value for x from 0 to 100 with an increment of 5. Okay, so create this script. You will discover that if you just create the script, you just type it into Matlab. Let me share my Matlab screen now. Okay, this is my Matlab screen. I've been able to restore it back to from layout. You click on default. It will bring back all the windows, current folder, workspace, command window, editor, all these things. So that's how I brought it back. Now I'm just going to start a new script, and I'm going to put this code. X is equal to, we have bracket open, and then, well, it's not necessary. You can also use increments to group if needed. So, but it says 0 to 100, increment by 5. Then y is equal to x. Then plot x comma y. So I can run this, or I can say first. I can say test plot 1, test plot 1, and then I run it. Okay, so this is it here. Hoping that you will see it. Let me see. Okay. Let me stop share. Let me pick. This is what I want you to see. Okay, so hope you have seen that. Okay, let me close it. Now, let me do a new share. Let me come back to this. Okay, when you run the Matlab file, you serve this. This is what we have there. Now, let us take one more example to plot y is equal to x squared. Now, you can have this script. Type this script. Then I open my Matlab. I say new script, and then I just put it there. Then you can see now, this is x equal to 1 to, now space can also be used to show array. And now this is 1 to 10. And then the x is starting from minus 100 to plus 100. Then incrementing in the middle 20. That is the incremental value. And then y is now equal to x dot, that means array exponentiation dot power raised power 2 dot power 2. Okay, that is x dot raised power 2, which means that each element of the array x will be raised to power 2. And then you now say plot in bracket x comma y. Now, if you save this, and save this as test plot 2, okay, test plot 2, and then we run it. So you see what you see here. So I expect you to see this. Now this is what you're going to see, and okay, this is what this is what we have looked at. This is what we have seen on the Matlab plot. Now you can change the code a little, reduce the increment to 5, and you see this. Then you can add title, label, grid line, and scaling on the graph. The X label and Y label commands does that, okay? And let's look at this one. You have the grid on command. The title command allows you to put the title on the graph. X label and Y label commands generate labels along X axis and Y axis. The grid on command allows you to put the grid lines on the graph. The axis equal command allows generating the plot with same scale factor and the spaces on both axes. The axis square command generates a square plot. Okay, so these are things to take note. So let me quickly, so want to look at this. Let me do a new share. Okay, I want to do a new script. And now this is the new code. This is incrementing by 0.01. Then y is equal to sine x, and then plot xy. As you're plotting it, then comma, x label will be x. Whatever you put in that code will be put on the x label. Y label is sine x in code, then bracket. Then you have title sine x graph in quotes. Then comma, grid on, comma, as is equal. So with this, I can just save this as test plot 3. And then you see the, let me change it to test plot 3. And then you see how, now let me run it. Okay, this is it here. Now, this is it here. Sine graph, that is, and then you have the Y label, X label. Okay, so that's about that. Just to be a bit very direct. Okay, so let me go back to this. So this is what we have got now. Now you can drop multiple functions on the same graph. Okay, create a script file and type the following code. Then is X, this is the value of X. This is Y sine of X. This is Y is equal to sine X. Then you have G is equal to cos S. Then you're going to plot X, Y, X, G. Okay, it's going to use X plus Y and X plus G. And then it's going to use this as the line plot. Okay. Legend, this is the legend that will be displayed like this and like that. So let's look at how it is. Okay, you can see. Now let me try this. Okay, new. Okay, now look at it here. X is equal to 0, colon 0.01, colon 10. That is starting from 0 to 10, increment by 0.01. Y is equal to sine X, G is equal to cos S, then plot X, Y, plot, and then XG. And then this value, we want to see how this is used, the legend and all this. So I'm going to just run it now. You can see everything is put in code here and come out this. So take note of that, why I save it with plot 4. Test plot 4. We need to test plot 4. Now I want to run it. Okay, you can see. Now this is it here. You can see this is let me look at. Okay. Okay. Now this is what I want you to see. Now you can see this is using this. Now I want to show you some things. Now I want to do a comment. First of all, let me copy this. Okay, I want to copy this and paste here. And I want to actually comment this. Then I want to do something. I want to see what happens if I only do this. Okay, Yes, it's running extra legend. You can see, okay. You can see that this is x comma y, and it's only sign that is taken care of. So it's only plotting the y. Heading is for y. I'm trying to just show you something. Okay. So that means I should have probably remove this, and if I don't want to get any, if I don't want to get, yes, I don't want to get any of this error, because now this is sine. Can you see sine x? Now let me now say, okay, wait, let me do something. Let me run this again. Now you can see, now this is using both dots and this to plot the graph. Can you see that? So it's dot dash that is using, that makes it to be tick. Can you see that? Dot dash that makes it to be tick like this. Okay. And so let me now bring this here. Let me introduce hold on. Okay, hold on, so that it doesn't erase the first one. Now let me remove this xg, and then let me remove this, so that that will be, instead of specifying them as one, I want to see. Okay, so let me save it and run it. Now, can you see now? So this is can see it holds this one for x, and then this for g. I mean, for this is for y, and this is for g. Okay. Now okay, let me try. Let me now try this again. I just want to see what is happening. So yes, I'm trying to experiment. Okay, you can see this is, let me say hold off and see what happens. Okay, so it will wipe off the first one. Okay, which is all right. So let me just comment this, comment this, comment this, so that I just want to see how this one works, so that you can see. You can see now. So this is sine x, this is y, and then this is g. Now, I also want to show you, supposing I remove this dot. Let me see what happens. Yeah, you can see. So it still uses different color, okay? But it only do that for G, okay? It's like nothing is for Y. Okay, let me do something. Let me say quote, asterisk, quote. Let me say comma. Okay, so let me run this. Okay, let me see whether this works. Yeah, it did not work. So that means everything's supposed to be in the same. Okay, let me see this. Yeah, this works. Okay, you can see this is for cosine, that is for G, then this is for sine. Okay, so you can see, let me see whether if they're together, whether that also affects anything. It doesn't affect anything. So you can see it uses steric for that, for the cosine. So let me invert this, see what happens. So I'm just trying to experiment with what that is. You can see sine is still the same, and cosine is still the same. So using this for cosine. So let me see this. So you can see it's still the same thing. So that's about that. Let me move to the next stage. Now, this is what we've been able to do here. Okay. And then now setting colors on graphs. W is for white, K is for black, B is for blue, R is for red, C is for cyan, G is for green, M is for magenta, Y is for yellow. You can draw this graph of two polynomial, and then you can specify this is for red, this is for green, okay? And you can see this is the array exponentiation. This is the value of X, the value of Y. Then you have this. So setting the axis scale, you can set the axis scale X mean, X max, Y mean, Y max. Then you can do this. So these are how to set the scale. This is using this, you have X mean, X max is 10, Y mean is -1, Y max is 1. And that is what you get here. You can also generate subplots. Subplot MNP, you can see that inside the same plot area. And all this can be what you can do. So quickly, I want to move to the next thing, graphics. You can draw bar chart, you can draw contour three-dimensional plots with Matlab. The bar control this, so you can use all this to draw your bar chart. You can see all this same thing goes for that with the X label, Y label, bar XY. Okay, this is X, this is Y. And you can draw contours with mesh grid. XY mesh grid -5 to 5 incremental 0.1, -3 to 3 incremental 0.1. So these are for the XY mesh grid, and you can do this, and then you have this contour. Okay, when you modify this, you have this. So try to test this code. Three-dimensional plots. Display surface given by a function in two variables. G is equal to f of xy, and then you see that the 3D surface map for this function G is equal to x e exponential raised to power bracket x squared plus y squared. When you do that, you can use this code to solve this function. Okay, here you just declare the mesh grid -2, 0.2 to 2. So this is minimum, this is maximum, this is the incremental, this is starting, this is the ending, this is the incremental. From this to this. So you start from -2 ends 2 and then incremented with 0.2. Then you have g is equal to x. Now this is, you are converting this into Matlab code. This is the Matlab expression for that. Okay, Matlab expression for that. G is equal to x dot, all these values will be taken one by one, then times exponentiation minus x dot raised to power 2 minus y dot raised to power 2, and then solve. This is surface graph. This is 3D surface. X, Y, G will be plotted. Then print minus depth graph dot EPS. Now this is what this is dash depth. Sorry, deep depths. Now when you run this, you see this. When you see this, then you can also use mesh command to generate a three-dimensional surface. However, the solve command displayed by both the connecting lines and the faces of the surface in color, whereas the mesh command creates a wireframe surface with color lines connected by point. So that's just the difference. When you try it, okay, let's try it so that you can see the difference in case you are skeptical about this. Let me just start a new script, and then let me save it first. It's test match 1, or let me say test subplot 1. Okay, let me run it now. Okay, can you see how it comes out? When you extend it, this is how it is. Okay, it really comes out fine. But now I want to close this. I want to change this. I want to see how, or let me just, it's not good to just delete your code. Just want to see if what I'm doing is going to work. So don't quickly delete your code that is working. You just comment it and paint another one, paste, and then change what you want to change so that if you forget, you can easily go back if something goes wrong. So I want to run it now. Can you see how it is? So this is just the equivalent of this. Can you see? Okay. So this is having this. This is mesh. Okay. Now, let me now uncomment this. Let me try to do the 2 and see whether it's going to work. I will have created subplots. Let me see if I can. Okay, let me just comment this so that you can see the difference. Okay, you can see the difference now. And see this one is more, has more depth, has more surface coverage. So the coverage, the surface covers everything. So this is really surface. Why this is, why this one is just a mesh, wire frame. You can see wire frame, no surface extends. You can see. So this is just wire frame. Okay. So that's about that. So I want to move on to the next. So this is that. So now I want to move on to this algebra. Okay, but this is all about symbolic computation. Okay, but first of all, you can start with just solving basic algebraic equation in Matlab. When you just solve this, you have the answer. Solve this, you have this. Solve this, you have this. solve equation variable. You solve this with this equation, becomes this is the equation. This is what v equals to now. Now you're just solving for v in this, so it becomes this. Just like you are making v the subject of the formula here. That's what then solving basically in octave. Root this. You have this. This the octave is just the open source equivalent to Matlab. Okay, then you have this solving quadratic equation in Matlab. Okay, the solve function can also solve higher order. Okay, like x squared minus 7x plus 12 is equal to 0. Then using this equation is equal to this, and then x is equal to solve. Then this the first equation is 1, then this is x2, then you see this. This is the answer. Okay, solve quadratic equation in octave. This is the same thing here. You can see this. You have to use this. Just picking coefficient of each of them, and then solve here. Now, solving higher order in Matlab, this is what happened here. This is a higher order. Okay, x minus 3 is equal to 2 times x minus 7 is equal to 0. And this is what is here. And then you have this. So this you can do with that. So this is just what are things you can do. You can also solve system of equation in Matlab with solve function. Okay, 5x plus 9y is equal to 5, 3x plus 6y is equal to 4. Then this script can solve that. X dot x, we solve for x, then x dot y, we solve for y. So now look at how it's done here. You can see this is the equation 1, this is the equation 2. And then you're not solving for this. So answer is x is this and y is this. In the same way, you can solve higher, larger linear systems. So this is what we use when we want to solve, 3, simultaneous equations like this. Okay, you can see this, and then you can do that. So in the same way, you can use this, just like we have this. So we're now using it here. Now, this now where is using sims. Okay, the expand and collect. Okay, look at the way this is. You can also use this method. Okay, and this method. Just find the coefficient of each of them, and then this, and then you look at their equal to. This is equal to. Then you see this such this. When you run it, you get the answer here. And this one, same way you can also solve the number given this. Now, let's use sim x, symbolic variable x, sim y, variable y. Or you can just say sim xy on the same line. It also takes it. It also takes it. Expanding equation, we have this, and then you collecting, you have this. Then the answer will give you this. So you need to have symbolic package when you are expanding this. So this is in Octave, but the Matlab is already there. So when you do all this is what you get. But in Matlab, we have already there. As I said, Octave is the open source equivalent of Matlab. Now you have factors and simplify that we have done in algebraic expression in the other lecture, another video. So it's just to show you that they are very, very close by. I mean, we are just talking about symbolic computation. Okay. Now this is what happens here. Factor, simplify, you get this. When you simplify this, you get this. Okay. Now, calculus. This is the same way. Talk about sim s, limits, limit this, not a number, that is that, then limit this, then in octave this is what happens, property limits in calculus. So this is what you can use that. I just want to show you that these are possible. So you can read more from that. So look at differentiation. That's what we have done before. Differentiate f with respect to t. You have this. So when you dip, you have this. It's 6t minus 4t raised to power 3. You can see this is what you're going to have. Differentiation of that. In octave, this is what you're going to have. It's going to do the same. Ft, you can see, we're going to have so you can see this is almost now these are the rules of differentiation which you need to learn that. Now all these can be done on your own. Look at them critically. I just want to show you that these are the function derivative of logarithmic and trigonometric functions. So all these things are possible in Matlab, as well as Octave. This is Octave, the open source equivalent of Matlab. You have to download that and install that. So then you can compute higher order with this, and you can find maximum minimum of a curve with this, symbolic computation. Seems x, and then you find this is the function that has been translated from this one to Matlab code. See how it is translated. Very, very important. You have to know how to convert it to Matlab code or Matlab statement. And then you can solve the derivative function also. And you can do a lot of things. Matlab will give you, you can solve differential equation, desolve, okay? And you can have all this, you can have this. Go through it at your own time and see. Just I'm trying to do an integration, the same thing we did before. You can have indefinite integral, you can have definite integral, and then you can have all these int 2x. You're going to have x to the power 2. Okay, that's. So when you're integrating this, and you have the, as I've earlier mentioned in one of the videos, actually, you discover that the integration of 2x, integration and differentiation, they are word and opposite. The same thing, you differentiate will give you the other integration, and then vice versa. So try to do that as I earlier demonstrated. I think I demonstrated with a very short. Let me just quickly use this to demonstrate that for you. Let me just quickly. Okay, let me just come to command. Let me clear my console, my command window, and let me say sims x, and then let me say integrate 2 times x. Okay, that is x raised to power 2. And let me now say diff x raised to power 2. What will I get? Can you see? 2x. So that's just it. So it's opposite. You integrate 2x, you get x raised to power 2. Differentiate x raised to power 2, you get 2x. That's what I'm trying to explain to you. So on that note, let me see if I can move forward. I think, yes. So the same thing, you can try all this. definite integrals, and you can do a lot of this when you have the limits for, then you can have x. This is very, very easy in Matlab to do a lot of complex symbolic computations. Okay, you have a script that you can run. F is equal to x to the power 3 minus 2x plus 5. Now a is equal to int. This integral, I want to integrate 10 of f 1, 2. Display area, display double a. So you have the answer. So this is the area. Area is equal to this. And then this one is what gives you this. This one display double. That is floating point. That is the that is the decimal places. Now this is what you find. You can use a lot of. You can use Octave also for that. The same thing for this. F of x equal to x squared cos x for minus. For x is less or equal to -4, and 9 is less or equal to x. So that is, from 4 to -4 to 9, taking the value. Okay, then XZ plot can be used to plot that. Then you see the plot here, and you see the plot, and then you now see the solution here. So very, very easy, or you need to understand what you are doing. And when you need them, you refer to them, and you get a better understanding. So this is just basic polynomial also. The same thing with pole-val, maths, all these matrix, all these. You can have this. You can find the root of polynomial with this. And you can use polynomial for fitting, polyfit, like we also use it for statistical analysis. We use Matlab for, but we're not going to do that now because of our time. But I will show you how you can go about that. So this is what you have here. Now let me look at the next transforms. Okay, I'm not going to talk about this. Laplace transform. When you need them, you will get to know them. But they're available. Fourier transform, they're available in Matlab. So when you get to them, inverse Fourier transform. When you get to use them, then GNU go Octave. Now, as I said, this is GNU Octave is the other from like Matlab, and not compatible with Matlab. So it's open source equivalent. So this is just comparing that. What you can do in Matlab, you can also do in Octave. Okay, and there are some that are not compatible, so you can have some differences. Now, my major area now is going to be Simulink. So I'm going to take the Simulink the next video. I will not combine it here so that the video is not too long, too big for uploading. So thank you for your listening. But I'm going to quickly do something. Okay, I'm going to do something. I want to show you something. I want to share Matlab screen. I want to show you the need for you to get properly acquainted with the help file. Okay, with the help documentation on Matlab. Very, very important. You see, as a new user, one of the things that you need to get familiar with is the documentation. You need to know how to check the help file documentation so that you'll be able to find new things and run with it. You see, well, what we have just done, they are very, very basic, very, very basic. There's more complex things you need to learn on your own when you need them, probably for your project or for any other thing, or as you progress in your educational pursuit. Now, for instance, I want to talk about maybe you are trying to search for something. Let's say I want to search for Simulink. I want to search for help on Simulink. I'll just search there. It will start, you know, searching, and it will display something. Okay, the search results. Aha, let me see if let me see whether I'm sharing the search result. Where is search result? Okay, now this is it here. Yes, so you can see Simulink. You can click on it. You can see Matlab simulation, all this. So you can click on Simulink, and then you can now begin to read more about that. You can say getting started with Simulink, and then Simulink production description, and you have tutorials here that can guide you, starting creating a simple model, and all these things can help you. You can see, you can easily create this model and get started. So I'm just going to show you a very simple model. I'm going to do this, as a way of teaching Simulink. So when I'm in Simulink, you will see I'll follow all these things. So thank you for your patience with me. Bye for now.